All right, welcome back to Geography 201. Now we're doing Chapter 19, Part 2. So now we talked a little bit about waves, and let's talk about how they form the coasts. How does the interaction of wind and water create coasts of either beaches or rocky coasts? Well, the first thing is we have to understand there are two types of coastlines, emergent and submergent. If something happens to make the land rise up out of the water or the sea level drop, the coast is said to be emerging. In other words, it's coming out of the water. When we have that type of coast, most of the coastline is created by erosional landforms. And we'll talk about that in a little bit. A submergent coastline is kind of the opposite. So the coast is either basically steady or actually slightly going under, or sea levels rising. So we see this often on continental boundaries that are, remember we have the active and passive margin, that are passive margins. So not right next to the coast, there's a coastal plain, a continental shelf, and this very shallow gradient. In a submergent coastline, the landscapes are depositional, and a beach is purely depositional. So sea level can change. We talked about if the crust is rising, and that can happen, right? Two plates can meet, one can get pushed up, but sometimes other things happen. Sea level can change for many things. So if we add more water to the oceans, that's called eustasy. So if we basically melt the ice at the South Pole and Greenland, that's creating sea level rise. It's eustatic in name. Okay. There are other things that make the water rise. One thing is if water is warmer, it expands. So 1 cubic foot of water will expand to be over a cubic foot as it gets warmer. And as we raise the global temperature, that is happening too. But what are some other things that affect the coast? So we talked about the sea level. Is the sea rising or falling? But other things are how much wave energy? Are there strong waves, small waves? Are there any biogenic structures, man-made structures on the coast? Is the tide high or low? And then what is the coast actually made of? What kind of rock? So from your book, we talk about many different types of coasts, but the one we're going to focus on for the main part are the anthropogenic coastlines. And these are the ones that have human modifications. So beaches. Let's talk about beaches, right? One of the things you had to do for your scavenger hunt before we dropped the whole beach part was there are actually 4 parts to a beach. And you were to go into a picture of one of our lakefronts and find one of these and label it. And I've found in many, many classes that people usually would say beach zone and just take a picture of a beach and actually not read the chapter. So maybe you're spared that. But there are 4 specific beach zones. Beaches may have different types of sediment or sand color or amounts of sand, but they all have basically these 4 sands. Or, I'm sorry, 4 beach zones. By the way, most sand that we see is that kind of light tan or yellow. It's because that's usually a quartz. And quartz is a material that weathers, takes a long time to break down, so that's why you have that. There are actually green and black and red beaches in parts of the world based on the rocks that are there. So here's the 4 sections. The first one, the offshore. The offshore is that part where it's basically where the ocean waves begin to encounter the seafloor. So that area here. When they encounter the seafloor, from the point they first encounter it to the point where they break, that's called the near shore. The foreshore is that area from where the waves break over and crash to as high as the water gets. So if there's a high tide, this is as far as in it goes. Lake Michigan doesn't really have a tide, it's not big enough, but there are some days when the waves are further in than others, and you've seen that. So that's the high water mark. And then the back shore is the part of the beach that is still beach with sand and sand-based landforms, but where it's not getting wet. So you see sand dunes, but you don't really find water for the most part. And eventually, as you get further away, and this isn't part of this chapter, but most areas, plants begin to grow at the edge of this. So the dunes are kind of that backshore between the forests and the beach. So, again, many types of beaches. and it depends on the material that is used there to build the sand. Because all beaches really are tiny little bits of sediment, or as we'll see in other things. I showed you before that the beaches in Lake Michigan are little tiny quartz crayons. If you looked at a handful of them under a microphone, it's all little pieces of quartz. This one right here is in the Galapagos. It's almost white. It looks like snow. And that's because most of the sand here is created from broken coral reefs, ground up coral reefs, either by natural actions of the coral reefs bumping against the waves. Some fish eat parts of it and poop sand. True story, look up the parrotfish. But at any rate, coral is the main source of material for beaches in the Galapagos, and so it's almost always this kind of light white, almost snowy type. This one is in Africa, but I also know there's one in Hawaii. It's a black sand beach. The rocks here come from volcanic material, like obsidian, and it has a high content of this black material that is ground up into sand. There's actually a green sand beach in Hawaii too. Most of us wouldn't consider this a beach, but it is. It's just instead of being sand as the dominant feature, it's pebbles and small pieces of gravel. And these rocks have hit each other and rounded off each other's sharp edges for millions of years. They call this cobble, and this is a shingle beach. But beaches are laid down by deposition. Something puts the sand there, the rocks there, the gravel there, and they also usually face erosion as well. So, if we talk about sand as the sediment, it usually is moved by the longshore current over time throughout the beach. And so sand will enter a beach offshore, and because of the longshore current, eventually be pushed along the beach, depending which way the current goes, and then eventually leave the beach. And when I say sand, it's just this top part that moves. So think about when you're in the water. Have you ever stood in the water and had the waves wash over your feet, and after a couple waves, your feet are half buried in sand? That's that sand being moved by the action of the water. I think it's also clear to point out here that when we talk about sand, we're only talking about the very top level. Okay. Now in Chicago and in Lake Michigan, the general pattern for the longshore current is on our side, the west side of the lake, the water moves from north to south. So if you were looking at Chicago Beach, water would enter from Evanston and leave in Indiana. That water that's leaving, by the way, not only drops off sand as it washes through, but it also takes sand with it. And so over time, beaches come to an equilibrium of the sand that's being dropped off or deposited and the sand that's being eroded. Because if they're out of balance, if the beach is eroding faster than there's sand coming in, then the beach is going to disappear. If the beach is getting sand deposited faster than it wears away, the beach will grow. So eventually they meet that kind of equilibrium. Another beach landform, one of my favorites, is the sand dune. Beautiful. The sand gets blown from the beach inland, it piles up just like in the desert, and eventually, because usually you're not in a desert, you get a decent amount of rainfall. Plants will grow on it, colonize it, so you start seeing what's called seagrass and beach dune grass. They kind of are the pioneer plants. Another thing you'll see is a sand spit, and this is sand in the water being deposited by that longshore current. It usually runs parallel with the shore. There are exceptions. A sand spit right here, the sand's being pushed, you can kind of almost see dropped off here and forming this kind of little arm of land. It eventually stops here because the water's gotten so deep. You can even see here that it's deep. It takes more sand to build it, so they grow to a certain length. But the current is just going this way and building them back up. These are the Indiana dunes over in Michigan City, Indiana, one of my favorite places. It's about an hour or two from downtown Chicago. You can see here's the beach, and the further inland you get, the grass and the plants begin to grow and begin to hold it in place. Some more things we see. I'm going to put these names up, and then we're going to look at them. It's just better to see the images. So the Baymouth Bar, the Tombolo, and the Barrier Island. So the Baymouth Bar is if a sand spit gets pushed on the coast and blocks off a small arm of the ocean. So right here, this used to be like a bay on the ocean, but the sandbar blocked it off. So now you have two separate bodies of water. This is called a lagoon. Sometimes if you have an island off the coast, a sandbar will form and connect it. And what happens is you have the coast over here, the island over here, and the sandbar filled all this in. That's called a tombolo. One of the most important ones, and we'll come back to this, are the barrier islands. So these are islands right here. You can see they're very narrow. They're basically just sand. Nothing else. No rocks, just sand. As the current of the ocean flows through, it pushes this longshore current and deposits these sands and keeps these beaches in shape. The entire eastern coast of the U.S. and most of the Gulf of Mexico actually has a line of barrier islands all around it. Here's another one in Virginia City. It's a very shallow, very flat lagoon behind it right here. And that leads us into our next section, modification of beaches. I'm going to pause it right here. We'll come back in just a little.